Hey guys, so today we're going to be talking about logarithms, and I don't want to say it's hard, it's just really different than anything you guys have ever seen before. So just take a minute and pause the video and copy down everything that you see on this anchor chart. So go ahead and copy down like everything. So all here, the orange, if you want the orange, but the laws are the most important, and we're going to be using these the most today. Make sure you get the green. So the change of base formula is very, very important. This is also very important. Move the exponent to the front. This is called the the product property. This is the quotient property. This is the zero property, and this is the identity property. So just take a minute, pause, write these down. I'm going to be referring to these by number very, very, very often, because there's about 10 examples that we're going to do. So just take a minute and pause. Go ahead and write these down. So let me get rid of this. So like I said, about 10 examples today. You might have to watch this a couple times just so that it sinks in. I really would prefer that I teach this in person, but what am I going to do? So let's go ahead and talk about what logarithms are. So logarithms are just a way to find an unknown exponent. Okay, so exponents, as you guys know, look like anything. They can take the form of a fraction, a decimal, a really ugly decimal, really ugly fraction, negative numbers, zero, imaginary numbers. So exponents just in general are not, just natural, found in the natural world of numbers. So that's why. So logarithms are a method that mathematicians use to find unknown exponents. And you cannot do all of these. You can do some of them by hand. Today it is going to be mostly by hand because we're going to be expanding, simplifying, and evaluating simple expressions. But most of the time, like in real life application, logarithms are hand in hand with advanced graphing calculators. So we're just going to get our hands a little dirty with the properties and solving very, very simple expressions, just to get, understand what it is like we're actually doing, and bouncing back and forth between the concept of exponents and then the function of logarithms. So as you saw on the poster, the formula, so I'm just going to put it like right here in the middle. So this is just your typical exponent, like what the general form of exponent looks like. So this is your base. I'm going to name it B. B for base. P for power. Okay, that's your exponent. Equals your answer. Okay, this can take any form. As long as this is your base, this is your power, and this is your answer. So anything raised to anything is going to give you an answer. And I just gave them, letters that make sense. So introducing logarithms. So log. So the B, the base, goes downstairs. It's going to be a very tiny font. I think it's subscript. I don't want to say superscript. It's subscript. So subscript B. So base is on the bottom. There you go, base, bottom. The answer is A. That's going to go in the big parentheses. Normal size font. So what we're finding, what we care about is the exponent. So we're going to set that equal to P. Okay? It's very important that you are able to bounce back and forth between these. This is your foundation for all the laws, all like the properties, simplifying, expanding, all that stuff. This is your foundation. Once you understand this, solving becomes less intimidating. Okay, so let's talk about example 1a. So example 1a, log base 2 of 16 is equal to what? So I'm looking, so I'm going to rewrite it in terms of this. So this is my base. So base 2. This is my answer choice. Okay, so this is the answer that I actually get. Equals 16. Oh, that's too far. Okay, so now what is the exponent that I need to raise 2 to get 16? So 2 to the what power gives me 16? And you should know that by by heart. It's 4. So 2 to the 4th power gives me 16. So 2 to the 4th power gives me 16. So my answer here is 4. Okay, so your goal is to find the unknown exponent. And this is just a very simple example. This is just for, you obviously can't do decimal exponents in your head. That's what a calculator is for. So example 1b. So I'm going to rewrite this in the form of BPA. I'm going to call it BPA. So log base 5, and the answer is a fraction. It's a fraction less than 1. 1 over 125. And this is actually the answer choice, or the answer that you're supposed to get. The question is, what is the exponent? So I'm going to rewrite this in terms of BPA. 5 raised to what power is going to give me 1 over 125. So now would be a good time to brush up on your exponent skills, which we did last week. You should know that negative exponents yield numbers less than the base itself. So 5 to the 1st power, just to recap, 5 to the 1st power. Now let's do 5 to the 0 power. 5 to the 0 power, that's actually also in last week's video, is 1. Okay? 5 to the 1st power is 5. 5 to the 2nd power is 25. 5 to the 3rd power is 125. So we're getting very close. Obviously it's not 3 because 5 to the 3rd power is 125. What if we did this? 5 to the negative 1. If you remember last week's video, 5 to the negative 1 power is the same as 1 over 5 to the 1st power, which is just 1 over 5. 5 to the negative 2 power, you can rewrite that as a nice fraction. 1 over 5 to the positive 2. So that's 1 over 25. So we're very close. So 5 to the negative 3 can be rewritten as 1 over 5 to the 3rd, which is 1 over 125. So your answer here is actually negative 3. So it is really handy to know those laws of exponents. Okay, so 5 to the negative 3 gives me 1 over 125. Negative 3 is my answer here. Let me go ahead and erase this. So it is good to know your exponents, how they work. Let's talk about example 2a. So 2a, I'm going to rewrite this in the form of BPA. So the log base 34, answer 34, what exponent do I need? So the base is 34. The exponent is what we were finding. And then the answer is actually also 34. So there is one number on this planet that satisfies that equation. And the answer is itself 1. So here, the answer is 1. 34 to the first power is going to give you 34. Okay? And this is actually an identity. This is actually a law. I think that's law number 5. Number 5. So this is going to cover a slightly very similar law. I'm going to rewrite this in the form of BPA. So base 8, what's the exponent? We don't know. That's what we're looking for. It gives me 1. Again, there's a single value on this planet that satisfies this equation. Anything raised to the 0 power is going to give you 1 all the time, always. So actually, 0 is your answer here. This is the 0 property for logarithms. Okay? So now let's talk about example 3. Example 3 is using the product property. So if you, I'm going to go ahead and rewrite it actually, just so that we can see it. So log, this is the property, log of base B mn is log bm plus log bn. This is the property for products. So if you notice in the actual law, m times n, which is product, is correspondent to adding. It's correspondent to adding. Very, very important. Notice the base stays the same. The only thing that you've done is you sort of expanded it. So we're going to expand using the property of the product. The log property. Oh my god. The log product property. Okay. So I'm just going to expand using this exact same format. M would be x cubed, and then n would be y to the 5th. So log, I'm going to rewrite this just like that. 4 x3 y5 is equivalent to, we're just flexing our muscles right now. We haven't really done any actual simplifying or anything like that. So I'm going to rewrite this. So that's log 4 x cubed, I like parentheses, plus log 4 y to the 5th. You can stop right here, or you can go an additional step, and you can go ahead and you can use the third property. So refer back to the laws that you just wrote down. Property number 3. This is what we're going to be utilizing. This is not exactly wrong, but it can be simplified further. So we want, and so the third law states that if the answer has an exponent attached to it, you bring that to the front, okay? Because we want our answer the answer. We don't want our answer raised to the 3rd power. We want the actual answer. So just to make it easy on ourselves, the law tells us to bring the exponent to the very front, okay? So it's actually going to be 3 log base 4 x alone. Same thing over here, plus 5, so bring it to the front, 5 log base 4 parentheses y. This is our final simplified answer. Well, it's not simplified, it's expanded. This is our most expanded answer. Okay. Very, very important that you understand the 3rd law and the 1st law, the product property and the one where you move the exponent to the very front. Okay, so now we're going to do example 4, very similar, except dividing / subtracting. This is called the quotient property for logarithms. So I'm going to rewrite the property here. This is property number 2. So it says log the base, everyone get it wrong, m over n. So same exact format, except now we're subtracting because, you know, adding and multiplying are like cousins, right? And dividing and subtracting are like cousins. So that's log, same base, m minus, very important, minus log base. And this is the property, and we're going to go ahead and utilize this to expand this expression. So m would be not this treated as 1, okay? So every term, every variable is going to be treated independently, and you're gonna see how I do it. So again, should be log. So I'm gonna start right here because it's a lot. So it would be log. The base is 6. So the numerator. So there's 2 parts to the numerator. X to the 9th power. So notice, here we're actually multiplying. This is actually a product rule inside the quotient rule. So plus, just like this example, plus log 6, same base, y to the 5. Now we actually utilize the quotient rule, so the dividing part. Minus this piece, log 6 z to the 3rd. Okay, so this is it expanded. It's not fully expanded yet because we want to utilize law number 3 again. Okay, and law number 3 tells us to bring that exponent to the very front. Okay, we want maximum expansion. So it would be 9 log 6x plus 5 log 6y minus 3 log 6z. This is it fully expanded. Okay, so this is our final answer. Okay, so go ahead and just take a minute if you want to pause. It's good to watch first and then pause the video, note take. And at least this is what I recommend. So just take a minute and pause and kind of soak it all in. I'm about to flip to the back. So go ahead and get all this info really quickly. Okay, I'm going to go to the back now. 4 more examples. These last 2 examples are actually pulled from the PDF that I posted. They're more of like the tougher ones. So example 5, write as a single log with a coefficient of 1. This is telling us a few things. This is telling us to simplify. It's also telling us not to apply law number 3, which, you know, is not a difficult law to skip or to do. So we're just going to go ahead and start. So 7 log base 12 parentheses x plus 2 log base 12 parentheses y. Oh no, actually it is telling us. It is telling us to apply the 3rd law. I'm sorry. So when we're adding, so every time you see an expanded expression of logarithms and you see adding, you have to think product property, and that's what it is. We're gonna use. This is the first property. So now, I'm just gonna let me do it in black. So the base is the same. So I'm going to do the reverse of law 3. I'm going to attach that coefficient of 7 to the x. x7. So I already took care of that. So I took care of this, completely finished. Now onto here. So when I'm adding, please remember the product property. So everything in the parentheses, we're going to multiply them. Okay. Y. So we're going to do the reverse of law 3 again. Y squared. Okay. And this is actually our answer. So here there's a coefficient of 7, and here there's a coefficient of 2. Okay. The bases matching are very crucial. If your bases do not match, then you can't really manipulate and use the properties like you want to. That's one of the most important things, is that the bases match. If the bases do not match, you have one other option. You can use the change of base formula, which I am going to talk about here. It's actually a really, really nice formula. But for the most part, when we're expanding, simplifying, we're going to have, the same bases. So that's it for number 5. And number 6, evaluate. So now it's telling us to actually solve. What is the exponent? So I'm going to rewrite this in the form of BPA. So this, again, is my base. This is my base. We're looking for the exponent, and the answer is 7. So this is one of those times where the answer is not a nice natural number. It's not 0. 0 is not a natural number. It's not 1. It's not 2. It's not 3. It's not -1. It's not -2. It's not 0. It's not any of those numbers. It's not any integer. Okay? You cannot do this in your head because the answer is a nasty decimal. Okay? So this is where change of base comes into play. You can, and it's actually also how you give it to the calculator. So what you do, let me rewrite it. So this is law 6. Log BA equals log base 10 of, A. Over log base 10 of B. So now, let me actually stop. Let me actually explain why 10 is so important. 10 as the base is really nice because 10 to like the 5th power, all you do is you just attach that many zeros to 10. So 10 as a base is actually, it's really handy. And it's something that there's a setting on the calculator for. It's actually called the common base. 10 is the common base. Okay. There's actually also a natural base. It's called natural base. The whole thing is called natural log, but I don't want to talk about that until later. For now, let's just talk about this whole change of base. So right now, B is not 10, but it will become 10, okay? And it's going to give us the same answer. So now let's rewrite this in the form of the property. So log base 10 of 7 over log base 10 of 5. Okay. And so now you just give it straight to the calculator. Your answer should be 1.20. Yeah, 1.20 9. Okay, so this is what I meant by you can't do most logarithm evaluations by hand. Right now, we're just understanding the properties and how they relate to actual exponents. But yeah, this you definitely need a graphing calculator with logarithmic capabilities. Okay. So now let's talk about example 7, which is number 23 on the PDF. And it is one of the uglier ones. So we're just gonna simplify this expanded expression. We're gonna make it as compact as possible. Okay? So I see adding, I see subtracting. That tells me product rule and quotient rule. And it kind of goes like left to right. So what we're going to do is we're going to treat everything with like in a parentheses like together. So this term, this whole term, and this whole term are separated by the minus sign, which tells me that this is going to go on the top of the fraction, and this is going to go on the bottom of the fraction. Okay, so because we're subtracting, it's going to correlate to the quotient rule. So this is property number 2. Okay, so I'm just going to rewrite it like fully, except in the form of a fraction. So 2 log x all over 3 log y plus log, I thought there was another number there. Okay, so now we're going to use law number 3. This is the law where you like you either bring the exponent down or you take that coefficient and you make it become an exponent. And so we're just going to compress it even further. So the top actually becomes log x squared all over log y cubed. Stop, because here is the product rule. And then z. Just like that. Very, very last step, we can just pull out that log and just put it like right on the outside instead of it being twice. So I'm going to simplify one last time to get log and then the whole fraction x squared over y cubed z. This is your final simplified answer. Okay? And so yeah, you really have to correspond subtracting with fractions / dividing and adding with multiplying. Okay? So this is going to be our last example number 8, number 42. If log of capital N is equal to log of x plus log of y plus 2 minus 2 log of z, find n. So in other words, it's telling us don't include like the logs of it all. The problem just wants us to find like how the variables look like. Kind of like just like this chunk, but without the log. So we're going to do this one. So I see adding, and I see subtracting. So few things, and I see law number 3 here, where we have to pull it up. Okay. So I'm going to go ahead and box them together. When you add, it's product rule, and then you subtract, this is your quotient rule. So this is going to go on the bottom of the fraction. It's going to go on the top of the fraction. I'm just going to write it just like I did here. And then I'm just going to compress slowly. I'm not going to try and do it. If you do it all at once, you will confuse yourself. Like, you will. So try and just do it step by step, at least for now. Later, when you master simplifying and expanding logarithmic expressions, by all means. But you got to take it slow in the beginning. So let's just do this. So log of x, so I'm just rewriting it, log of y plus 2 all over 2 log of z. So now I'm just going to simplify the top. Okay, so the top is telling me to do the product rule because of that plus sign. Okay, so it's going to be log of, let me see, it's going to be x log x times y plus 2 over, here is law number 3, so log of z squared. Let me see here, give me a minute. It could just be, so I'm just going to do this. Let me see if this works. xy plus 2x all over log of z squared. And then you pull out that log. So I'm just going to go up. I don't have any room. So you pull out that log. Log parentheses xy plus 2x over z squared. Is that it? Is that the answer? Hold on one second.